This video describes the use of a Zahn Cup to determine the viscosity of paints used in the coil coating industry in accordance with ASTM D4212, Standard Test Method for Viscosity by Dip-Type Viscosity Cups. It is a fast, simple method that is widely used in industry. There are many manufacturers of Zahn Cups. The cups are supplied with various orifice sizes. The smallest, a number 1 Zahn Cup, has the smallest orifice and is used for very low viscosity fluids. The largest orifice, a number 5 Zahn Cup, is used for very high viscosity materials. In the coil coating industry, the most common Zahn Cup is number 4. Although Zahn Cup manufacturers produce their cups to a standard shape and size described in ASTM D4212, there may be slight differences between manufacturers. Whenever Zahn Cup viscosity is measured between different laboratories or coil coaters, it is recommended to use cups from the same manufacturer. The nominal capacity of the cup, for example, is 44 milliliters, but may vary from 43 to 49 milliliters depending on the manufacturer. What is viscosity? Viscosity is a property of the liquid's resistance to flow. The following table shows a few common liquids and their respective viscosities. In this table, centipoise is the unit used to state the viscosity of a material. The higher the centipoise value, the higher the viscosity. Controlling viscosity is imperative to producing high-quality pre-painted metal that meets all the physical requirements and provides the essential aesthetic appeal. Viscosity that is too high could produce ropey flow on a coil coating line. Viscosity that is too low may lead to inadequate dry film build. For these reasons, manufacturers of coatings formulate their product to run within a narrow viscosity range. Viscosity is affected by temperature, and a narrow temperature range is also specified when testing for the viscosity of a coating. The use of a Zahn Cup is designed for testing Newtonian and near-Newtonian liquids. A Newtonian liquid is shown on the left, where the paint flows uniformly from the spatula. A non-Newtonian liquid, a common house paint in this case, tends to slump off the spatula. For a house paint, non-Newtonian flow is a property formulated into the coating. When brushing or using a roller, the viscosity thins out, but once applied to the wall or ceiling, it will not drip or run. Coatings of this type are not affected by the shear applied to the coatings. Most coil coatings fall into these categories, but a notable exception is plastisol coatings, where a test method such as ASTM D2196, Standard Test Methods for Rheological Properties of Non-Newtonian Materials by Rotational Viscometer, or ASTM D4287, Standard Test Method for High Shear Viscosity using a cone plate viscometer, is recommended. The viscosity of a Newtonian liquid does not change as the paint undergoes shearing, such as mixing or while being roll applied on a coil coating line. A near-Newtonian liquid demonstrates only a slight viscosity change under shear. Most coil coatings are near-Newtonian, and measuring viscosity with a Zahn Cup is appropriate. Before taking a Zahn Cup measurement, it is important to adjust the temperature of the sample to be within the specified temperature range. The viscosity of paints and related materials may be highly dependent on temperature. Differences in temperature between measurements may produce substantially different viscosities, up to 5% per degree Fahrenheit. On a coil coating line, it may not be possible to make a temperature adjustment, so it is important to record the temperature at which the viscosity measurement was made. A temperature correction curve may be constructed for each liquid by plotting viscosity, seconds, against temperature over the expected temperature range. With this curve, a viscosity determined at one measured temperature may be converted quickly to a viscosity at another temperature. It is important that the Zahn Cup is at the same temperature as the paint. This is accomplished easily enough by allowing the cup to remain immersed in the paint for at least 10 seconds. Additional considerations. Be sure to use a timing device where the readings can be taken with a resolution of 0.1 second or better. The paint to be tested should be visibly homogeneous and free from any foreign material or air bubbles. A small number of bubbles are acceptable, but paint with considerable entrapped foam will produce an unreliable reading. Procedure. The Zahn Cup is completely immersed in the paint, withdrawn from the paint, and the time for the material to flow through a hole in the base of the cup is measured. The cup is lifted vertically out of the material in a quick, steady motion. As the top edge of the cup breaks the surface of the paint sample, start the timer. The cup should be held by the loop handle during the measurement process. Most manufacturers equip the cup with a ring through the loop handle. Holding the cup by this ring will help to ensure that the cup hangs vertically. During the time of flow, hold the cup vertically no more than 15.2 centimeters or 6 inches above the level of the liquid. Stop the timer at the first definite break in the stream at the base of the cup. The efflux time in seconds constitutes the viscosity. It is common to make only a single measurement, but for greater precision, the mean of 2 or more measurements should be taken. Following each determination, clean the cup with a suitable solvent and a soft brush. Use no metal tools in contact with the instrument, as nicks or wear of the drilled orifice affect the accuracy of the cup. It's also very important that the cup is completely dry from cleaning solvents. Solvents attached to the interior wall of the Zahn Cup can affect the viscosity reading. A useful checking technique is to measure the efflux time for a new cup with a given standard fluid, then check the cup periodically with the same standard fluid at the same temperature to determine if the efflux time has changed. Standard fluids are selected depending upon the cup's orifice size and viscosity range. If the time changes 10% or more than your process tolerance permits, the cup should be discarded and replaced. If the change is less than 10%, it may be appropriate to use the cup as is, or by applying a correction factor to subsequent efflux times, depending on the degree of precision required. The correction factor is equal to the original standard fluid efflux time divided by the current efflux time. For example, by using one of the standard fluids, if the original viscosity value, OV, of a new Zahn cup is 25 seconds, and if the current value, CV, of a cup that has been in use for a while is now 28 seconds using the same standard fluid, then the correction factor would be as shown here. If you measure a paint's viscosity at 35 seconds with a cup that has been in service and has a correction factor of 0.89, it is appropriate to correct the 35-second value by multiplying by the correction factor as follows. Keep in mind that Zahn cups cannot be calibrated. There is no way to adjust the efflux time. Other efflux devices are also available and work on the same principles as described here. Examples of these devices include the Ford cup and the Shell cup. Viscosity is one of many important parameters measured to ensure the appearance and long-term performance of coil coatings. This video has provided a useful overview of the appropriate process used to measure paint viscosity with a Zahn cup. For more information on coil coating, visit the National Coil Coating Association at coilcoating.org.